Welcome students. So now in the concluding part of the discussion on this course, that is the project selection and finance. Basically it's a project management course. We have discussed almost all the facets of the project management, right from the idea generation till the networking techniques, which we are going to discuss now in these three next lectures. This you call it as the 58th, 59th and 60th lectures. So with this discussion, we are going to complete the entire discussion on the course. So this part we are going to discuss is that it is we call it as networking techniques for the project management or for the projects. So networking technique, as you all aware are, that these are basically the structures, or the you call it as the diagrams. These are the basically the kind of structures which we develop to know it, that what are the different activities involved in the projects and how much time each activity is going to take. So what is the, say, budgeted time for the project, how much actual time is going to be taken or can be taken, so that entire thing is under control, everything is under control, and we can finish the entire project in the given amount of time. So we use these networks or these structures with the help of these networking techniques, which are developed with the help of these networking techniques. So they are going to be very helpful in implementing the projects and controlling the projects and completing the projects within the given span of time, and controlling the cost also. That means the resources also is required to build the projects or maybe to create the ventures. So they can also be controlled. So these are very useful techniques, and we are going to learn about that how with the help of the networking techniques the project control can be applied, and how the projects can be implemented and say finished in the given amount of time and for the given the cost of the project. So under this process we are going to discuss these certain important points. So first thing is we are going to learn about is that how we can develop a project network, then how we can go for the time estimation, which is maybe for the completion of different activities or maybe the different events, and determination of the critical path, then scheduling when resources are limited, because always the resources are limited. They are not the case that we have the unlimited resources. In that case anybody can do the business or can move into the business. So we always have the limited resources, whether you call it as the finance, human resources, technology or maybe other inputs, they are always limited. So how we can schedule in a way that these limited resources give us the best output. And then we are going to learn about these two important this networking models, PERT model and the CPM model. And then we are going to learn in the end about the network cost system. So now we are going to learn about these two networking techniques, project networking techniques, which are PERT and CPM. So PERT and CPM is basically, you call it as the first technique, that is the, but we call it as, that is a program evaluation and review technique, right? This is the program evaluation and review technique. This is the PERT, and this is very important technique which is used for developing the structures, networks or diagrams for the projects which are involving the high amount of uncertainty, high amount of the risk also. And in that situation means those projects which cannot be visualized in advance, which you cannot maybe say with the confidence that if we start on one particular date, we will be able to arrive at the completion on that particular date, and we would be able to complete the work on the given amount of time, because these are, say, surrounded by high amount of the uncertainty, and when there is a uncertainty there is a high amount of the risk also. And sometimes it may be possible that you are not able to take anything or get anything out of the project which is called as a meaningful. So to make the things meaningful and to remove the element of uncertainty and to minimize the risk involved in the projects, we use this PERT analysis, or maybe the PERT as a networking technique, which is basically probabilistic in nature, because you cannot be certain. If you are not certain that at what time you are going to start, at what time you are going to end, how much time is available with us, how much time this project is going to take, different activities involved in the project are going to take. Similarly, how much resources we have and how much resources are going to be taken by this particular project. So when the project is highly uncertain, it involves a high amount of the uncertainty, high amount of the risk. So developing the networks in such kind of the projects, we take the help of the PERT, program evaluation and review technique. And this basically technique is designed to handle the risk and uncertainty, to handle the risk and uncertainty, and it is suitable for the projects like R&D projects, right? In the R&D projects, you're not sure about that if we are trying to find something, so we will be able to get certainly at the end of the day the output, the desired amount of the output. We are not going to be sure in the beginning, so there we have to take the help of the PERT. For example, you talk about the pharmaceutical projects where we are trying to find out the molecules, new drugs. So as I told you sometime in the past in the discussion, that for developing a new molecule, it takes around 10 to 15 years of the time for developing a new drug, and minimum 15,000 crores of Indian rupees. So you can understand that how much uncertainty is involved in that process. And even after spending so much of time and so much of the money, the molecule may not be found out. New drug for say treatment of a certain disease may not be found out. So this kind of the projects involve a high amount of the uncertainty. So we deal with such projects. With the help of the PERT, we can develop the networks and we can try to control the affairs of such projects. Similarly, the projects which are maybe aerospace related projects or maybe the other projects involving new technology. So where you are going to test the new technology, so such projects are also going to be uncertain that whether this technology will work or not work, or in particular area or in particular settings, this technology will work or not. So the projects which are highly uncertain and involve high amount of the risk, they are controlled, or maybe the networks can be developed for such projects with the help of the PERT, and the time required to complete the activity is highly variable, right? The time required to complete the activity is highly variable. Therefore, we call it as the probabilistic because it has the probabilistic orientation, right? It is the probabilistic orientation. So because of that reason, we call it as probabilistic, because there's nothing certain. High amount of the risk is involved in the project, high amount of the uncertainty is involved in the venture. And if you want to control the affairs of the venture with the help of some networking techniques, then the PERT is the most suitable technique. Similarly, second technique, you call it as the CPM, critical path method, right? This is the critical path method, which has a deterministic orientation, which has a largely deterministic orientation, and it is applied to the projects having fairly stable technology and are relatively risk-free, right? Which it has a, let's say, a stable technology, fairly stable technology, and relatively they are risk-free. Means the high amount of the risk is not involved in such projects which are maybe repetitive kind of the ventures where already the technology has been tested, already the product has been tested, and we are going to set up the venture in new market maybe, but we have already tested that venture in the one other market. So when we are expanding the market, we are maybe using this kind of the networking technique, which is called as the critical path method. And because high amount of the uncertainty is not involved under such projects or on these projects, and these are highly, you call it as the certain, and the lesser amount of the risk or almost no amount of the risk is involved in such kind of the projects where the CPM can be used. So that's why they are called as the deterministic projects with the deterministic orientation. So the projects which are more deterministic, where the maybe the risk involved is almost negligible, which are largely maybe work in the certain conditions, and the outcome expected from the project is going to be certainly available there. They are maybe can be controlled, or networking tools can be used, is the CPM. But the projects which are surrounded by the high amount of uncertainty and risk, and where the outcome is not assured, we start working on it, we make our full put in our full efforts and we make full attempts, but at the end even it may not be possible that we will be successful in getting what we want to get. So in that case, we use the networking technique as the PERT. And next thing is that widely diverse projects are amenable to the analysis by the PERT and CPM. So it means the PERT and CPM are largely applicable to large number of the projects, means any kind of the projects you talk about. If it is a venture, if it is a project which is going to be set up to manufacture a product or a service, maybe it's related to manufacturing sector, it's related to pharmaceutical sector, maybe it's a industrial projects, maybe it's a R&D project, aerospace, or maybe defense related production. Any kind of the venture you want to set up, there the networking techniques can be used, both PERT and CPM can be used, and you can easily develop the networks with the help of these two techniques. And those networks which entail the activities and events are going to help us to control the affairs of the projects. And if you are able to control the affairs of the project, it means you are able to control the time involved in building that venture, as well as the cost involved in that building, that venture can be taken care of, can be controlled, and we are able to know in advance that how much time is going to take and how much cost is going to take. And if we want to reduce the time and maybe the cost associated to that, with the help of these networking techniques, we can reduce the time involved in building the venture, and even at the same time the cost part can also be taken care of. So in this case, the PERT and CPM, when we are going to understand about these two techniques, PERT and CPM, so we can say that the common characteristics of the projects which make them amenable to the analysis by the PERT and CPM are, right, the common characteristics of the projects which make them maybe them amenable, or which may be controllable, or maybe taken care of by the PERT and CPM are, maybe there are some characteristics which we have to understand where you can apply the PERT and CPM. You cannot apply it in all the projects. Only in the projects where these characteristics are fulfilled, there the PERT and CPM can be applied, and you can develop the network structures with the help of these networking tools and control the affairs of the project. So first thing is, the project can be broken down into well-defined set of jobs or activities, right? You can divide it into that. First, you can divide into different activities, right? Entire venture can be, when you are setting up the entire venture, it can be divided into, broken down into different activities or well-defined jobs, so that we can sequence those activities, that which activity we are going to conduct first, then which is going to be the following activity, then the following activity, so that preceding and succeeding activities are known to us. And if these activities are known to us, we can easily maybe set up a connection or let the linkage and interlinkage among us these activities, and finally we can create a structure which is going to give us the best output. Next thing is, the activities must be performed in a certain sequence which is technologically ordered. So one after the another, not haphazardly, but in a sequence we should be able to know it. Many people are involved in designing these structures who are technically very good experts in these techniques, as well as they know the entire venture also. They know the different activities involved, what is their sequence, how they can be performed one after the another, that is known to them. And next thing is, within a defined sequence, the activities may be started and stopped in an independent manner, right? So you can start any activity, you can stop any activity in an independent manner. That is also there maybe is the another characteristics, that is another important requirement of the projects. So basically, entire venture is a bunch of the activities, right? So you perform certain activities, you break down the whole venture into different activities, you set up a sequence of those activities, and those activities are such kind of that which can be independently started and independently can be stopped. If these three characteristics plus some other requirements of the project or the venture are fulfilled, then certainly we can develop a structure network diagram, and that diagram helps us to understand that how we are going to build the venture, from where the venture is going to start, where is going to end up, how much time it's going to take, how much cost it's going to take, and finally how the structure looks like. So if you are able to develop a structure successfully, then it may be possible that in between the building of the venture, if some of the people leave the venture or maybe transfer to the other venture and new people join, they would also be able to control the affairs of the project, because that structure is in front of them. They would be able to understand that, oh, these are the different activities being performed in this venture. They are independently, say you can call it the presented activities, and their sequence is also properly defined and it is presented in the structure. They are independent, they can be started or stopped independently, so anybody can understand. So these structures help in the knowledge management also. So once this structure is developed, then building the project on the basis of it, as well as controlling the affairs of the project, is not difficult, and that can easily be done. Now we understand that what these are the project networks or the network structures, how we can develop the diagrams, how we can develop these networks and these structures, and finally how we can take care of the control of the project or the project activities. So when you see that we want to develop the network structures or maybe the project networks, when we want to develop for controlling the affairs of the project, so it means we have to understand it in totality, that basic to the PERT as well as the CPM is the network diagram. This is the first thing which you have to, this is the basic of the, say, implementing the PERT and CPM. If you want to take the help of the PERT and CPM, so basic requirement is developing the network diagram. And the network diagram also referred to as the project graph, right? Also referred to as the project graph shows the activities and events. This is most important thing, shows the activities and events of the project and their logical relationship. A simplified network diagram for the dinner project, right, means for understanding it, maybe we are not dealing with very complex ventures or maybe the complex networks. We have just created a structure here which is for the dinner project, and dinner is also a project these days because you cook so many things. So itself it's a project, and for understanding it, means beginning with the simplistic thing, we want to start to understand this networking techniques. So for this purpose, for example, if you want to see that, as we know that these are the basic requirement of implementing the pertinent CPM. So for a dinner project, if you see a structure which is developed here, so you can see here we have the two things in this structure. One thing is these are the activities, and second thing, these are the events, right? So these are the 4 events involved in it, and these are the 4 activities as well. And this way the entire project of the dinner can be completed. So this structure clearly shows us that if you want to have a project like inviting some guests on the dinner, so it's going to be a big venture for us, and for that purpose, how we are going to manage that project to make it very successful and very, maybe you can call it as controllable. So first thing is the first event, means you see in this structure this circles given, they exhibit the events of the project, or maybe the events, important happenings in the project, right? So they are indicated by the structures, and these arrows are indicating the activities involved in the project, which are logically sequenced and can be started and stopped independently. These are some of the requirements. So and the entire project can be broken down into different activities. So for example, this dinner project is there. First we are breaking it down to the different activities. So first activity is we have decided to go for the dinner. So first activity is the send invitation, then second is the prepare dinner, third one is the receive guest, and fourth one is the take dinner. So these are the independent activities. The entire project can be broken down into the independent 4 activities. So send invitation is independently can be started, can be stopped. It has no relationship with the preparation of the dinner. That's a different activity. Receive guest is an independent activity, and take dinner is also an independent activity. So first condition of the network structures is fulfilled. Second thing is they should be logically sequenced. So they are logically sequenced, that we are sending invitation, we are preparing dinners, we are receiving guest, and we are taking the dinner. And third one is they can be independently started and stopped. So sending invitation, you can independently start or you can stop it also. You can prepare dinner independently, you can start preparing, you can stop preparing at any point of time. You can receive the guest independently, and you can take dinner independently. So no interrelationship of these activities is there. So in this case, we have the 2 important things. One are the circles which are indicating the events, and second is the activity. So events do not require any resources. They are only indicating the happening of something, completion of something, maybe some activity, beginning or completing. Both they are indicating beginning or completing of some activity, and in between the arrows they are indications of some activities, and these activities require resources. They consume resources, that is the time as well as the cost. So for example, the first event is we thought of, say, inviting somebody on the dinner, and then we started giving the invitation, sending the invitation. So sending the invitation is the activity which requires the resources. But when we completed the invitation sending, so means we completed the second event. Then at the same time we started preparing the dinner. This was the activity because it requires resources, time and cost. And when we completed the dinner, so it is a event 3, and we can say that completion of the dinner preparation is achieved here. Then we receive the guests, and finally same time we are going to maybe finish the dinner preparation and receive the guest, and finally then next thing is the taking of the dinner. So activities, the sending invitation, prepare dinner, receive guest, and take dinner, they are the activities because they consume resources, time and cost, whereas these events 1, 2, 3, 4, these are indicating the beginning or completion of certain happenings, and here they are not requiring any resources, but significantly indicating about that some activity has been completed. So arrows are the completion, means the arrows when we say, so the front part of the arrow say marks towards the say completion of the activity, and the beginning tail of the arrow is marking the beginning of an activity, and then head point of the arrow is indicating the completion of that activity. So we have the activities involved here. For example, this is activity 1 to 2, this is activity 1 to 3, and this is activity 2 to 3, right? This is activity 2 to 3, this is activity 2 to 3, and in this case this is activity 2 to 3, right? This is 2 to 3, and this activity is 3 to 4, right? This activity is 3 to 4. So we have performed 4 activities here: 1 to 2, 1 to 3, 2 to 3, and 3 to 4, 4 activities and 4 events. So this is a simple structure of maybe inviting somebody on the dinner. So dinner is also a good project these days, and with the help of the PERT and CPM, we can develop such a structures which help us to understand that how much different activities are involved in this venture and how many events we are going to start or complete, so that we can successfully start and we can successfully complete. So when you talk about the PERT and CPM, so PERT is basically event oriented. So it marks the beginning or completion of some activity. These are called as events. And the CPM is basically activities involved, which is say kind of say arrows, which with the help of arrows we are showing it here, and these arrows consume resources, these activities consume resources. So basically say PERT is the event oriented and CPM is the activity oriented. Now the development of the project network. For the development of the project network, what you have to do is the network diagram is constructed in terms of activities and events, right? It's clear. We have already seen that in terms of activities and events, we are developing the network diagrams, and activity is a definite task, job or a function to be performed in a project, right? For example, prepare dinner is an activity. So that activity was maybe you call it as this 1 to 3. So this is an independent activity, is an activity. An activity is represented by a arrow, right? This activity is represented by a arrow. I told you. The head of the arrow marks the completion of the activity, and the tail of the arrow marks its beginning, right? And the length and direction of these arrows have no significance. Only you have to look at the head and tail. So head is say marking the completion, and tail is the beginning of the activity. And similarly, an event is a specific point in time indicating the beginning or the end of one or the more activities, right? Beginning or is a beginning is indicating the beginning or end of the one or the more activities. It represents a milestone. It represents a milestone, means when I told you that happening of something, milestone, and does not consume time and resources. It doesn't consume any kind of the resources. It's only marking the milestone or happening of something. For example, in our dinner project, that is the event 2, right? When you talk about the event 2, it means we have already completed the invitation sending. So we started with the event 1, and at the event 2 we completed the sending of the invitation. So event 2 marks the completion of the activity, send invitations. So it means you should be very clear now what is an activity and what is an event, right? Activity is basically a specific task or a job or a function which we have to perform. It is marked by the arrow, and it consumes resources, which is time and cost. And say head of the arrow marks the say completion of that particular event, and tail of the arrow marks the beginning of that event, right? When you talk about the tail is the beginning of that particular happening or that particular event. And as far as the events are concerned, so events are basically the completion of beginning or completion of certain things, certain happenings, and they are indicated by, so we begin something, so that is the first event, and when we complete that particular activity, so that is a completion of that particular event. So events are basically milestones, or maybe they are indicating the beginning or completion of some of the activities, but they do not consume any resources. They do not consume any resources, and they are helping us that we started from the event 1 and we went to the last event. So from the event 1 to the last event means it shows us that we have completed all the events, and now this entire venture stands as completed. Similarly, all the activities from the activity 1 till last activity, we have performed all the activities in the sequence, and at the end of the completion of the last activity, we can say that the project seems to have been completed say fully, successfully. Development of the project networks, we are continuing with the discussion. So, identify the activities and proceed and succeed means identify the activities, right. So, what we have to do is developing the project networks. So, we have to identify the activities that proceed and succeed and can be performed concurrently. So, we have to identify, and on the basis of this the network diagram we have to develop. So, those activities which can proceed and succeed, that is very important, which will, because sequence is important. So, which will come first, which will come after that, which will proceed, which will succeed, or sometime any activity which can be performed concurrently, and after that we will develop the network diagram, and we can follow the forward or the backward method for developing the networks. Either you start from the first event and go up to the last event, first activity, and go up to the last activity, or in the backward process you start from the last event or activity and come back to the first event or the activity. So, either way you can complete the structures, you can develop the structures. Now, the rules for the network constructions, rules for the network constructions. So, when you talk about the rules for the network constructions, we have to be very careful following these rules, because if you do not follow these rules, then the structures developed may be not correct and they will not take you to the right, maybe say results or maybe the outcome, and finally we may feel confused that what we wanted to achieve and where we have landed up. And finally, the objective of maybe controlling the affairs of the project has not been achieved. So, we have to be very careful about the rules of the network constructions, and when you talk about these rules, so understand these rules very carefully. First rule is each activity must have a preceding and a succeeding event, right. Must have a preceding and succeeding. What must have a preceding and succeeding event? For example, in the dinner project, we have a preceding event, this is 1, and this is succeeding event 2, and the activity send invitation is completed like that. Then we have to go for same as we have seen the activity 1 and 2 in the dinner project. Number 2, each event should have a distinct number. That is very clear, because otherwise you will be confused which event comes first and which event comes after that. So, each event should be given a distinct number. And third important rule is there should be no loops in the project networks. No loops in the project networks means, if you see this kind of the structure, this is a structure which is a loop structure, and this kind of the structures are not allowed. What you are doing now, this project is not moving forward, right. This structure is not taking the project forward. We are starting from 1, we are at 2, we are at 3, and then again we are at 1. So, we are just creating a circle kind of a thing. We are going from one place to the another place. Within that circle, we are roaming. We are not able to proceed further. So, we are creating a loop kind of the structure, and these loops are not allowed. This is incorrect structure. So, we have to avoid this kind of the structure. This must be a forward looking structure or backward looking structure, not a structure, a circle kind of, where you are revolving around that structure and you are not reaching anywhere at the end of the day. Next thing is, that is no more than one activities. No more than one activity can have the same preceding and succeeding events. No more than one activity can have the same preceding and succeeding events. So, this is also not correct. So, this is because 1 to 2 they all have the preceding and succeeding, both the activities have the same preceding and succeeding events. This is also not allowed, this is also not possible. So, we have to avoid this. And there can be dummy activities. Very good. There can be dummy activities. We all understand, yes, dummy activities can be there. Dummy activities are basically logical connections between the different events, because without showing this connection, our structure will not be complete. But these are not requiring any resources. They are dummy, means they are not consuming any resources, but they are logical connections between the events, so that the entire structure looks complete. So, in this case, for example, you see this activity is the signified with the dotted line is the dummy activity. Here also this X is the dummy activity. So, we are performing the activities here 1 to 3 and 1 to 2 and 1 to 3. These are the 2 activities. So, this is 1 to 3 and this is we are going to do as the 1 to 2, these activities. So, these are the 2 structures, but certainly if there is a connection between 1 to 2 and 1 to 3, so there must be a connection between 2 to 3 also. So, though it is not requiring any kind of resources, but we are saying that the structure would be complete when all these 3 events would be completed and all these 3 activities would be completed. So, 2 are practical activities, right, logical activities which are requiring resources, but 1 is only dummy activity which is not requiring any resources, but yes, it establishes the logical connection between the 2 events, that is the 2 and 3, and that is why we are showing it with the dotted line. Similarly, this activity X is also a dummy activity. So, you can understand that if you want to perform the event 8, So before that, event 4 and 6 must be completed, and for that activity P must be completed. Similarly, if you want to complete the event 9, so before that event 5 and 7 must be completed, and before that activity Q must be completed. So this is a connection, right? But see, if you do not establish a connection with a dummy line here, or maybe a dummy activity, in that case it will look like that these are the two parallel projects going on, 4 to say 4, 6 and 8 events, and 5, 7 and 9 events. There is no connection, but actually they are connected. So to show a logical connection, we are using the concept of a dummy activity here, that is X. So it's establishing a logical connection between the events 4 to 9, right? But because this activity X 6 to 7 is not consuming any resources, so that's why it is shown as a dotted line, and it is shown as a dotted line because it is a dummy activity. So dummy activity is possible, but the loops are not possible. No activities can have the same preceding and succeeding events. These things are not possible, and these things are not permissible in the network structures. Then you talk about here is, that is the we are trying to understand the concept of the network diagrams with the help of a simple illustration. And this illustration is of a building project, and for that purpose we are given different activities, and we are given the interrelationship among these activities, right? So we have to establish, this is a very critical situation, that the people who develop, who are expert in the network developments, they are very clear and very good experts in developing the interrelationship among these activities. And these are the different activities in a building project. So these are activities A to I. First is lay foundation, B erect framework, C install the millwork. So you have to divide the whole project like this. This is the classical example. D is install wiring, E is the install plumbing, F is plaster walls, G install siding, and H decorate the interior and finish the exterior. So these are the different activities. We should be able to divide the whole project into, whole venture into. So we have identified that these are the activities involved in this entire process, and we know all these activities, and this is the logical sequence, or you call it as the relationship and interrelationship among these different activities. Once we have known all this, now in this case we have developed these structures. These are little less clear. So you can see here I have taken these structures from the book that is a Prasanna Chandra, Projects by Prasanna Chandra. So you can refer to that book. That's a very good book. So just because we had the lesser times to manage the time, I thought rather than developing a structure myself, we should take it as ready-made. We have taken from the book Prasanna Chandra's Projects book, that's titled as Projects. So this example is there, and these structures are also there. So you can easily understand how these network diagrams are developed. First part is saying that activities 1 to 2 is the lay foundation, and then it is the next one is the 2 to 3 is erect frames. So event 1 is the beginning of an activity, and event 2 is the ending of an activity. So the tail of this arrow is indicating the beginning of an event or an activity, and or beginning of an event, and then head is indicating the completion of that event, event number 2, and then next one is the erect frames. So like that we are starting the structure. So this is the first part of the structure, this is the second part of the structure, and this is the final structure we have developed. So we started with this 1, 2, 3, 4, then we have the 5, 6, 7, 8 and 9. So these are the 9 events involved in this structure, and these are different activities. The activities which we saw in the previous slide, they all are logically sequenced here. And now looking at this kind of the structure, when this kind of the structure is available with us, anybody can implement this structure. So even people in between are transferred from that project to the new venture, and new people join to implement that remaining work. So easily anybody can understand from these structures. So number one, these structures help in the knowledge management. Second thing is they help in the controlling of the time as well as the cost, means the resources also, and facilitate the completion of the projects on time. So you can easily understand the sequence laid down here. So we are starting with the lay foundation, erect frames, then we have to go for the next thing is this is the B, and then we have to go for the next activities, install the millwork. Independently we are doing all these, and install the wiring, then the install plumbing, then the plaster walls, then install the sidings, and then finish the exterior, and then decorate the interior, and finally you are starting from this event number 1 and you are ending up event number 9. So you can understand that how easy and how the structure is going to help us in understanding the whole implementation of the project and taking care of the affairs of the project, controlling the time and cost, means all the resources, and completing the venture on time. So this is a very good example, simple example of the network diagram which can be developed with the help of some information given with regard to the activities and events to be performed in a project. Then now we talk about the next important thing is the time estimation, and when you talk about the time estimation, normally we have the three kind of the time estimates, right? This is the optimistic time, most likely time, and pessimistic time. Optimistic time is the time which is normally taken, is the most, you can call it as the ambitious time, that we are going to complete the project in the minimum possible time. I won't say it's a minimum, but optimistic means that without wasting any time, any resources, we are going to achieve the venture or going to build the venture in that say period of time, which is called as the optimistic time. Then we have the most likely time, which has the allowance for certain ups and downs, and pessimistic time is most time period, which is lengthier one, and you call it as the lengthiest. And finally, the time and resources required are much more in this, and it has a lot of unforeseen difficulties. So optimistic time is the same required, is a time required with no hurdles or complications, when we are expecting that no hurdle and complications arise in the project. In the most likely time, you can say there is some allowance for the uncertainties, right? Making the allowance for some unforeseen delays. So some unforeseen delays can be there. So every time maybe we try to achieve the optimistic time, completion of the project in the optimistic time, but sometime it may not be possible. So we normally go for the second estimate, most likely time, that having some allowances for some uncertainties or some unforeseen delays, that is normally the time, that is the most likely time we believe in, that we would be able to complete the venture in that. But if there are some unforeseen delays or unforeseen unusual complications arise or unforeseen delays arise, for example, we are going to construct a highway, but in between there is a tunnel, we have to construct a tunnel also, we have to dig a tunnel and we have to construct a tunnel also. So in that case, you can say, though we have the three time estimates, but you can understand that maybe the most pessimistic or the pessimistic time estimate may be the final one, when we will be able to achieve the target to build the or construct that highway, because tunnel is such a thing, when you start digging the tunnel, so it can create any kind of the unforeseen difficulties, and it may take any amount of the time. So our approach always is to achieve the things in optimistic time, but if we are able to do it in the most likely time also, still it is better. But if it is a pessimistic time, so we have to find out what were the reasons that we had to take the pessimistic time, the longest time, and unforeseen difficulties, how they created the problem, and how we have finally handled them and taken care of them. So this is a very critical situation, that we are to achieve the projects in the given amount of the time, but if we are able to do it in the most likely time also, still we are very successful and able to achieve the venture or say control or complete the venture within the given span of time. So for obtaining the time estimates, now in this case what happens, people who are to build these networks, they have to take the time estimates from the people who are responsible for, say, estimation of the time required for these activities. So what happens, there is a two set of the people in any organization. One who is expert in developing these networks, maybe the PERT network, because why we are talking about the PERT network, because these three time estimates are most likely are going to be present in the PERT networks, because it involves the high amount of uncertainty, and when there is a high amount of uncertainty, you are not sure about the time going to be taken. So in that case, we have to have the three estimates minimum. There can be more than three estimates of time also, but we believe that we can have three estimates, that is the optimistic time, most likely time, and the pessimistic time. So for this network developer, he has to take the time estimates from whom? So he has to take the time estimates from the people who are involved for maybe visualizing these activities in advance, these events in advance, and to estimate the time required for completion of these activities and events. So these people supply these estimates to the PERT designers or maybe the network designers with the help of the PERT, and finally they develop the networks. So when they develop the networks, so we have to be careful that these following points are important. They should be borne in mind while obtaining the time estimates from the people who are responsible for it. Number one, time estimate should be obtained by skipping around the network, right? Whole network we have to take into consideration. We have not to follow a specific path. If we are only asking the time from the person who is estimating the time, that give me the time for a specific path, then he may be biased and he may give you the shortest or maybe the most likely or the pessimistic time. So, you don't care about that. You ask him that you simply give me the different activities we are going to perform, different events we are going to start and complete, and how much expected time per activity is going to take. So, you skip around the whole this network, and finally you decide that this is going to be my structure. As a PERT designer or the network designer, PERT people have to find out that if these activities are, all these activities are involved, these events are involved, this much of the time is required in these different activities, then finally the network to be developed would be something like this, taking this much of the time, this much of the resources. So, they have to take the whole network into consideration, not a specific path. This is the first point of caution. Second thing is, so these estimates, that is the optimistic time, most likely time and the pessimistic time, should be independent of each other. They should not be linked to each other. They should be independent of each other, that this is my optimistic time, this is my most likely time, and this is my most pessimistic time, and developed independently. Third important thing is, time available for completing the project should not influence the estimates of the optimistic, most likely and the pessimistic times. Time available is not the consideration. Time available will be only worked out after developing the structure. We are not limited by the time available. This time available is not a limiting factor. That should not be limiting factor also. That should not be influencing factor also. We have to find out that looking at these activities and events, and after developing a structure, how much time we are going to take, and then we can go for the crashing and other kind of the processes which we will discuss in the subsequent slides, in the subsequent lectures. So, there we can minimize the time, but originally in the network, how much time, total time is expected to be taken by the project, that should be shown, and it should not be influenced by that we have only this much of the time available. We have only, for example, 3 months, 90 days available. If only 90 days are available and you cannot build the venture in 90 days, it means it is impossible. So, let the network engineer find it out that how the structure looks like, how much time this project is going to take involving the different activities and events, and then you try to find out that okay, this is the normal time going to be taken, but can we reduce the time or can we increase the time depending upon the resources with us, depending upon the cost estimates with us, that can be done. But don't initially keep in mind the time available, otherwise the structure will be influenced by the time available and that will not be the correct structure. And how to obtain the time estimates? Obtaining the time estimates. So, it means finally it should be made known that optimistic time and most likely time and pessimistic time are the estimates and not say scheduled commitments, right? We are talking about the obtaining of the time. So, it means these are only estimates. These are only estimates and not the scheduled commitments. So, we have to find out, ultimate purpose is that we should achieve the target in the optimistic time, but if we are not able to achieve the target in the optimistic time, we should be able to do it in the most likely time. And even if we go to the pessimistic time also, so finally you say these three are only estimates, not scheduled commitments. So, finally it will depend upon the situation on the ground, how much time is taken, but our hope and attempt is that we should be able to complete the project, if not in the optimistic time, then in the most most likely time. And the next thing is the estimate of the TO, TM and TP should include allowances for occurrences which are generally considered as the random variables, right? Random variables are like, for example, weather conditions and administrative delays. They should keep the allowances while working out the time for the random variables, but not the allowances for natural variables which are considered as the floods and wars. We cannot see, we cannot visualize, we cannot foresee in advance that flood is going to take place or a project will be delayed or war is going to come up, so the project will be delayed. No allowance for that. But yes, while making these estimates TO, TM and TP, the network engineer should be having some allowances for these random variables, that may be because of some administrative reasons the project may be delayed, because of the weather conditions the project may be delayed, then the true time estimates can be obtained. Otherwise, if we are not taking these random factors into consideration, random variables into consideration, then in that case it may be possible sometime after completing the most pessimistic time also, we will not be able to complete the project. So, have these 3 time estimates, have the scope and the say provision for the random variables, and then independently develop these 3 time estimates, obtain these 3 time estimates and use them for developing the structures. And finally, we can calculate the average time, because ultimately we are going to calculate or use the average time in the projects. So once the 3 estimates of the each activity are obtained, the expected value of the activity duration is calculated. The expected value of the activity duration is calculated. The expected value is the TE, right, which is a TE here. The expected value is the TE here, that is a say expected value of activity duration is calculated, and for calculating TE we can use this formula, where you call it as TE is the weighted arithmetic average time, then TO is the optimistic time, TM is the most likely time, TP is the pessimistic time, and when TM is multiplied by 4 and the whole divided by 6, so you can find out the weighted arithmetic average time, which is going to be the final time which can expect that the time we are going to use for developing the structures or networks, so that we can control the projects in an appropriate manner. At the moment, we will stop here, and in the next part of discussion we will talk about the determination of the critical path, and taking into consideration all these time estimates, average time, and say all these 3 different time estimates, we will be learning about that how we can develop the critical path and how we can use the different time estimates, and finally how we can develop the critical path, means a path which is going to be the best path, in which we are going to show all the activities, all the events, and we are going to have a fair idea about that in how much time and at what amount of the cost the project is going to be completed. So at the moment we will stop here, and in the next lecture we will start with the determination of the critical path. Till then, thank you very much.